Welcome to raigurukul.com. In this video, we'll discuss about video bitrate, which is an important concept. Bitrate measures down the data that is to be transmitted at single point of time. It's a de facto standard for measuring bits per second, kilobits per second, or Kbps, or the megabits per second, that is Mbps. This defines the rate at which data is passed through the communication channel or network. It can also be referred to as data rate. So in this video, we'll discuss about the problem statement or the problem with streaming video, overview on streaming, evolution of bitrate, deep dive into bitrate, and at the end I will tell you a very important tool. By using that tool, we can convert our low resolution video into high resolution video. This will help us to get a lot more insight about the tools on the video which we are converting. We can also see different aspects of the video. Without wasting time, let's jump into the video. And if you are visiting this channel first time, please hit subscribe button and don't forget to hit like. When we talk about the problem statement, what is the streaming video over the internet, streaming network, and evolution of bandwidth over the years? In traditional way of the communications on transmission of media, which goes from one era to the next era, which help us to get the video in downgraded resolution. The problem statement is streaming video over the internet, streaming network, and evolution of bandwidth over the years. So if you can remember the previous era where we are getting the videos in low resolutions and that video are having some glitches. These are the network glitches, or sometimes the streaming content glitches. Evolution of the bandwidth, how the bandwidth has been evolved from the low bandwidth to the high bandwidth, how we are getting SD to HD and then ultra HD, how we can cope up with social media and web to establish the presence of video on the internet as a part of day-to-day product offering. Streaming video still hard, where we can get these type of video with lot many works performed in background. So in tech fields, when we talk about the video streaming or when we talk about the video and audio streaming, in that case it's very difficult to manage all of the components together. There are lot many things are working in the background in silos, but we are getting a video in good quality. So this is a complicated process from streaming from one place to the other place, where broadcaster has to spend lot of money and time to send these type of video to the end user. It's very hard to manage entire pipeline from production to delivery with consistency, because encryption is involved, then encoder, decoder, these all technologies are working, and trust me, this will eat lots of effort and time from the end broadcaster. So we'll talk here in detail how we can cope up with and how we can resolve these issues practically. Now, first of all, what is video streaming? So video streaming, as I said, if you can see here, this is the image how video source are adopted. You can see here video sources are there. Then it will go to the MPEG2 elementary encoder, where MPEG2 elementary encoder have some additional information that will be packetized and send this video into packet format, that is called as packetized elementary stream, that is PES, and post that it will go to the transport, that is a MUX format, and that MUX will convert into the transport stream. So if you can see here, video and audio, both the data are sent separately, and this will be MUX together and send it to the TS. Even data is also sent separately as a part of packetizer. So every content is sent in part of packets, and from the packets this will be delivered into the MUX, where the MUX is doing the scrambling and sending into the transport stream. So when we talk about different ways of or streaming video, so there are three ways how we can stream the video. First is streaming, where we can see the video from different sources, and these are the contents which is hosted on any particular locations. Then we have live streaming. So broadcaster is sending a live stream to the end user, so that end user is watching a regular live stream, and these streams are sent via the network or any transport stream. Let's say we are using a DTH signals or IPTV, so we have to be permanently connected with the internet in terms of IPTV. But when we are watching the DTH, we should have our setup was installed, and through setup box we can see that content. Third is video on demand. Video on demand is nothing but a YouTube or Netflix, where the content is hosted, where we can see this content post installing or by using any applications. So whenever the people will need, they go to these type of applications, do log in and post that they can watch the content whenever they will need it. Now when we talk about video and audio bitrate, so video bitrate is referred to the speed at which video is transmitted at a given point of time. The more the speed, larger the chunk of data is transferred at the given point of time. However, the considerations of correct bitrate depends on which device the videos are being played. In typical cases, an approximate value of 2 Mbps is deemed to be a good quality of video on web, whereas the standard definitions of DVD has 6 Mbps. In its simplest term is how much information or video sends out per second from a device to an online platform. Technically, bitrate means the quantity of data required for our encoder to transmit video or audio in 1 single second. Bit rates are measured in Bps, that is bits per second, Kbps, Mbps, Gbps and Tvps. In live streaming, Mbps is the most common bitrate unit for videos and Kbps for the audio. So if you can see here, streaming media will have different contents where we can transport through one channel and send it to the user. So user will watch this content connecting their devices either through phone, laptop or monitor. Next is audio bitrate. They are defined as the compression rate used in the audio. Bitrate is termed as the number of bits used in playback time per unit that allows or shows audio after source coding. So they are defined as the compression rate used in encoding files in audio. Expect more the bitrate, better the quality of sound. So when we talk about is a higher or lower bitrate is better, yes, it goes without saying, to fetch a great quality of video, the higher bitrate is recommended. Putting differently, setting the video output in higher bitrate will provide higher image quality as compared to the lower bitrate. When we compress a video, we typically have to tell the video compression software that it should not exceed a certain bitrate. For example, if we tell our software to compress at 3 Mbps, the software will compress each second of the video such that only 3 MB of data on an average is sent to the decoder or the player. That is what bitrate means. When we talk about bitrate, we are essentially talking about how much the encoder is expected to compress the data while sacrificing video quality. Then VVR and CVR comes in picture. So what is VVR and CVR, and we will see the difference here. CVR is constant bitrate and VVR is variable bitrate. When we talk about the comparison between two, so CVR is ideal for time sensitive streaming, where we can see this is very much common when we talk about video streaming. VVR is capable of producing high quality streams. When we talk about the second pointer, it produces consistent results. If we set it to the 15 KB or 1.5K Kbps, our bitrate will remain at 1500 Kbps. Ideal for transcoding without time constraint is a part of the VVR. Historically popular data is available in CVR, but in VVR does not negatively impact video quality. CVR will help us to widely compatible but VVR is not widely compatible. CVR is well suited for the multimedia encoding, but VVR is well suited for the VOD, that is video on demand transcoding. Ideal setting for live streaming encoding is available in CVR, but it's not there in VVR. So this is the difference between variable versus constant bitrate, which is very important part. And when we talk about VVR and CVR, this plays a very important role in terms of video streaming. Now, when we talk about the bitrate measurement, bitrate is measured in bits per second, as I said, which is referred to as Bps, while kilobits per second is fine to use for measuring audio files. The same value is not suitable for the video because the volume of footage is large. We would rather talk about it in megabits per second. Bitrate is measured in per second. Avoid mixing up Mbps and Mbps, which means differently things. Megabits, that is Mbps per second, refers to uploading and downloading speed, while megabits per second is used to define the wealth of info transferred. So if you can see here, Mbps and these two terms are a bit different. So Mbps represents the bit capacity of a network connections, while Mbps refers to a unit of measurement for the file size, that is 1 Mbps equal to 8 Mbps. So that's the major differences between this. So we have to avoid this mixing of these two concepts. That's why bitrate measurement is very important. Now when we talk about the evolution of tech and bitrate over the years, so first pointer comes in mind like early internet audio. So let's consider one general example here. When I was in 1998, while at TM Century, when someone gave me a folder full of photocopied multiple on a new company called broadcast.com, headed up by some guy by the name of Mark Wen. I remember returning it to the person who had me review it with a comment that this wasn't going to make it. What kind of Yahoo would invest in something like this, right? Available bandwidth was very limited. However, broadcast.com was doing sports talk, which means that low bitrate MP3 could be tolerated. The rest is history. By 2000, TM had sold its technology department to a German company called On Air, and they had developed an MP3 encoder that we had up for a long time. It was a mono stream of 64 kilobits per second, which of the D sounded good. If you can compare the today's era devices, if you can see about the earlier phones, that devices consumes or having low bandwidth or having resolutions low, but when we will compare the same devices in nowadays, we are getting ultra HD. So this is the major differences we can talk into previous or then the journey started till here. So eventually, once the royalty issues were worked out, several entrepreneurs would establish music channels using high bitrate, that is MP3, 128 Kbps and above. Not all browsers would accept MP3 directly, which means that either Windows Media Player or another player needed to be downloaded, which is corporate America was a big no-no. Port blocking issue would be continue to halt the progress of streaming audio and limit it to home computers. Second is high quality low bitrate. AAC is the major important part, and especially the ultra low bitrate HEVC shows the ability of the internet to deliver high quality audio and low bitrates, including bitrates that would allow streaming to some of the new generation 3G phones. These phones require different streaming protocols over the well-established ICY HTTP, that is shortcast and icecast protocols, or RTSP, that is real-time streaming protocol. While this shows great promise, it was never pushed by the phone carriers, which had no problem prompting downloads but had no desire to promote a technology that required real-time streaming reliability. Nonetheless, streaming gained in popularity as almost all browsers now played MP3s. Adobe Flash Player delivered, and almost all PCs become a way around the port issues. However, both methods required fairly high bit rates, and despite the ability to be played on most browsers, Audio streaming was being discouraged by companies whose 10 base T connections were being overloaded. Third is segmented and adaptive streaming. There were still issues. However, with the number of listeners increasing at the advent of streaming video, carrier networks were getting overloaded and stream reliability became a big issue. To address these issues came two new streaming formats, that is HTTP live streaming developed by Apple and MPEG- an evolving MPEG standard based protocol that has made some impact in the video field, but due to the lack of standards for metadata has yet to make an impact in the audio only field. Both HLS and Dash use segmented audio files and support adaptive bitrate streaming. However, the lack of metadata standards within Dash has hindered the development of players capable of playing those streams. Now, when we talk about how does bitrate affect video quality, so this is a very important part in broadcasting, is doubtlessly an effective method to connect with the audience, but what is the key to producing professional looking live video? Some might say it is the gear we use. This is the only partly right, because the gear is only a drop in the bucket. What's more crucial is the bitrate. It records video at, since this has a direct impact on the size of the file and video quality we will end up with when streaming. A higher bitrate results in better quality and larger file sizes. This is where we should consider keeping them balanced. The larger the file, the more buffering issues it may cause, since the server resources of most viewers can hardly process an extensive file quickly. Quite the opposite, a lower bitrate results is worse quality and less professional look for the video stream. There are several other factors influencing video quality, so we are sure we had found the golden means in the size of the quality and video. But here the frame rate is the rate at which the images of video frames are played to create motions. The frame rate is represented in frames per second. The standard rate is 24 FPS for most video format. However, there can also be videos with higher FPS ranging from 30 to 60. Frame rate plays a significant role in live streaming, especially when it comes to the broadcasting fast tempo sports or music events. On this point, higher FPS leads to a better output video signal. Resolution indicates the number of pixels that form the video frame and make up its image. Generally, more pixels brings a sharper look for the frame. The video resolution type often used for the broadcast are represents in 480, 720, 1080 and 4K terms. Resolution matters when it comes to the improving the viewing experience on large display. It will make more sense to get a stable stream with lower resolution or frame rate than to choose higher values and end up streaming with delay and glitches. Now, it is again important to understand bitrate versus quality trade-offs. So if you can see here, these are the standards video where the streaming is normally having quantization stepwise, where we can see different aspects like city, crew, football, foreman, harbor, mobile, news, soccer. So these are the power channels where we are broadcasting. So in a normalized bit rate of standard A, if you can consider this example, so standard and second is the news video for different quantization stepwise, and it is compressed and uniform quality encoding is showing here. However, in second video, we can see a pairwise normalized bitrate difference under given Q values between ROI based encodings with Q minutes, that is 16 inside ROI, and the uniform quality of encoding for standard and news channel is bit different. So you can see here quantized is 64, Q 40, 26, and here we have exactly same pattern. So this measures the bitrate versus perceptual quality trade-offs for non-scalable ROI based encoding using S264 encoder. Based on the quantitative measurements, a bitrate model and a perceptual quality model are developed to predict the bitrate and perceptual quality of the ROI based encoding so that the adaptations decisions can be easily made at the client side. The experiment shows that ROI-based encoding achieved more perceptual quality than the bandwidth trade-off. Moreover, it is observed that the quality gain is influenced by content features, quantization step size, and the efficiency of ROI detections. Development of more effective ROI detection schemes will improve the perceptual quality even further. In addition, since only one ROI and fixed ROI size were used in this paper, the impact of multiple regions of interest and different ROI size would be addressed in future work. Now, what is frame types and how this will impact the bitrate, or where we can use in video bitrate. So when we talk about the frame rate, so let's understand by using flipbook video, where a pad of paper had an image on every page, and when we flipped through the page quickly, the image would appear to animate and move. So in this video we can see here how video works, whether digital or old school films video in a series of still images that when viewed in order at a certain speed. There are several other examples we can see here. When we are moving this flip cards, we can see the order is changing, and where we can see just like a motion type of video. So frame rate is speed at which those images are shown, or how fast we flip through the book. It's usually expressed as frames per second or FPS. So if a video is captured and played back at 24 fps, that means each second of video shows 24 distinct still images. The speed at which they are shown trick our brain into perceiving smooth motions. When we talk about the type of frames, we have three types of frame, that is I, P and B. So I, it means intra predicted self-contained. P, frames are predicted from last I or P reference frames. B, frames is bidirectional, predicted from two different references, one in the past and one in the future, and thus out of the order decoding is needed. So why does rate matters? So frame rate greatly impacts the style and viewing experience of video. Different frame rates yield different viewing experiences, and choosing a frame rate often means thinking about multiple factors such as how realistic we want our video to look, or whether or not as per or planned techniques like slow motions or motion blur effects. For example, Hollywood style movies are usually displayed at 24 fps, since this frame rate is similar to how we see the world and creates a very cinematic look. Live videos or videos with a lot of motions such as sporting events or video game recording often have higher frame rates because there is a lot of happening at once. A higher frame rate keeps the motion smooth and detail crisp. On the other hand, people who create animated GIFs will often sacrifice detail for a smaller file size and choose a low frame rate. Now, style or realism. So the frame rate of video quality impacts the look and feel of video, which is in turn determines how realistic the video appears. This concept ties directly to how we naturally see the world. When we see the motions, there are different types of FPS will appear. Frame per second. So first is 24 fps. This is the standard for movies and TV shows, and it was determined to be minimum speed needed to capture video while still maintaining realistic motions. Even if a film is shot at higher frame rate, it's often produced and displayed at 24 fps. Most features, films and TV shows are shot and viewed at 24 fps. Second is 30 fps. This has been the standard for television since an early days and is still widely used despite producers moving towards a more cinematic 24 fps. Videos with a lot of motion such as sports will often benefit from the extra frame per second. The reason of using 30 fps is strangely complicated, and it mainly has to do with televisions and electricity standards set a long time ago. If we want to learn more, we have to understand the video standard or modern video standard. third is 60 plus FPS. So anything higher than 30 FPS is mainly used to create slow motion video or to record video game footage. Additionally, as technology continues to evolve, many smartphones are now capable of recording at 60 FPS as well. Next is motions. The next key variable to take into consideration when choosing a frame rate is the amount of motion we can add inside our video. This one's pretty straightforward. If we have a lot of movement, we will probably want to capture a higher frame rate. This doesn't necessarily mean we will want to produce at higher frame rate, but capturing at higher frame rate ensures a high level of detail for the amount of motion captured. The higher frame rate also allows for more flexibility when editing to help decide what's best for us. 24 FPS is stated minimum speed needed to capture video while still maintaining realistic motions, and we also have 30 FPS and 60 plus FPS here as well. Now, what is resolution and how this again related to bitrate? So video resolutions, a resolution of video is width by the height of video. The unit of measurement of video resolution is pixel. So resolution indicates the number of pixels that from the video frame and make up its images. Generally, more pixel brings on a sharper look for the frames. The video resolution types often used for broadcast are represented in 480, 720, 1080 and 4K terms. Resolution matters when it comes to the improving the viewing experience on large display, or if we want the video resolution generally indicated in couple of ways, where we can increase the value mentioning the values in width and height, that is 1920 into 1080 or 1280 into 720. The resolution you can see here with the width and height. So 1080p, that is 1080p is 1920 pixels is the width and height, and these are the categorizations divided here. Now, bitrate and bandwidth limits. When broadcasting, we may experience bandwidth limits for both upload and download transfer. Bandwidth defines the maximum throughput of the network needed to upload and download data. Hence, it transfers the data between the web and our local network. So the larger the data request, the higher the bandwidth it needs to pass through. When the bandwidth is insufficient, it induces breakpoints and slows down the transferring process. So the bandwidth, same as speed, can be measured in Mbps. Many internet providers specify how much bandwidth their networks allow. If they provide 100 Mbps and 5 Mbps for download and upload consideringly, the network can easily cope with downloading content. However, for live streaming, the given upload bandwidth may be quite restrictive. There are several recommended parameters where we can use. In S264, we can use 32 Mbps. So average internet speed in the US is 18 Mbps, but in HEVC, we can use 15 Mbps. So how we can deal with the bandwidth limit? The issue of scattered bandwidth is not the final verdict of broadcasting. There are still a few ways to surpass the limit from both sides, streamers and viewers. So first is high efficiency video coding, that is HEVC or S265. This is an extended version of S264 or AVC, which is the industry standard for video compressions. HEVC enables compressing video without affecting the quality. It allows for more reduced file size and consequently more reduced bandwidth. Besides, if the viewers have devices compatible with S265, they also need less bandwidth. Hence, they can get more chances to watch the stream in premier quality. So tips are here. We can leave only the wired connections on. So go with the multi-streaming services like different other applications like Gumlet. Make sure to use modern software and hardware without any hitchups. So we'll talk here about Gumlet at the end of this video. So please be available from till end of the video. So in handling mechanism, we have discussed about high efficiency video coding, that is HEVC or S265, and again we'll talk in detail about ABS. So these are the recommended settings suggested for our best quality content. Now let's understand HEVC. What is HEVC? It matters a lot at today's world, and we will get many benefits and advantages of using this standard. A video is HEVC compatible if we talk about HEVC, that is high efficiency video encoding or video coding, as the compression techniques that gives a better performance than previously used standard. The source video is compressed using an HEVC encoder. It creates and stores a compressed bit stream that can be decoded into a sequence of frames using a video decoder. High efficiency video coding is similar to the previous S264 or AVC or MPEG-2, but has improved vastly. So if you can see here, there is a video source where we can see the partitions, then it will go to the predict and subtract, then it will transform, then entropy or encode, and finally it will convert the compressed HEVC video. After that it will become, this is the decoders and these are the encoders. This is exactly opposite process will be performed at the time of decoder. So when we are using HEVC, we can save almost half the money and bitrate if we choose to stream HEVC video instead of an AVC encoder. We can run the same quality of media at almost half the data. In many places where Wi-Fi connection is very slow, by using HEVC we can stream HD video using fewer data. If we used to run 480p content at 1.5 MB per second, we could run 720p content at the same rate using S265. The file format gives much more efficiency to video compressions, and it is eminent for the future. High efficiency video coding is similar to S265 but having advanced capability. So when we talk about the video encoder, the encoder will first of all divides every picture into many smaller units, that is called as partitions. Then it predicts each units through an intro or inter predictions and removes the predictions from the original unit. Finally, the residue left after this subtraction is transformed and entropy encoding is done to all the informations. Then video decoder will reverse the steps performed by the encoder. As I said, it performs entropy decoding first and extract various elements of the encoded bit stream. It rescales and inverts the transforming stages before predicting the units and adding the predictions to the inverted transform. Finally, it will reconstruct the decoded video for us. Now, finally, the ABR. A progressive video streaming is the one signal that is called as adaptive streaming. So adaptive bitrate streaming is technology designed to deliver video in the most efficient way possible and in the highest usable quality for each specific user and device. It's not to be confused with the progressive streaming. Adaptive bitrate streaming solves each of the two main problems with progressive streaming: quality and buffering. Adaptive streaming allows a video provider to create a different video for each of the screen sizes that we wish to target. So progressive video streaming is one single video file streamed over the internet. This type of file is often .mp4 but can be in many different formats. The progressive video can be stretched and squashed to fit different screen sizes. But regardless of the device playing, if the video file will always be the same. The problem with progressive streaming are two major problems. Like the first is quality. A video that is only 1280 into 720 will never play at correct quality levels, and screen that is 1920 into 1080 pixels, it will stretch and we will see pixelations. The second is buffering. If the user has a low quality internet connections and cannot download the video stream fast enough. So what is a good bitrate for the streaming? So most videos plays at 24 frames per second. So the internet connection needs to download at least 24 frames every second to avoid buffering. So adaptive streaming solves this by adapting to the speed of the user internet connections. So these are the challenges which we have discussed and different technology aspects. but here we have a very interesting tool or very interesting product. By using this product we can resolve these problems. So Gumlet is helping to resolve all this problem. So it is publishing a video online to our own without using popular video hosting platform. This will save our time and cost and effort. Like if you want to host any particular video into YouTube, it's very hard. It involves transcoding our original video files into various resolutions, figuring out correct bitrate, selecting the optimal formats, and many other settings required to be done. So not to mention the computing cost, engineering efforts, and time spent to build and maintain in each pipeline. So Gumlet is providing a fully managed video ingestions, optimizations, and delivery software built for developers and project managers. With Gumlet, we can automate our entire video processing pipeline in a minute. We can ingest video from multiple sources with APIs, direct upload, and user-generated content. Videos are optimized and transcoded using the latest codecs and layered with adaptive bitrate streaming and as per the type encoding for the best streaming quality with the lowest possible bitrates. So HLS and dash support is also available here. The output stream can be played on any device or browser or OS using a video player. With DRM, sign URL and assign referrals video productions users safe streaming. Gumlet also provide insights and analytics at no cost for everyone. Simple UI with Gumlet ML algorithm can set the best parameter for us, where we can use a significant time setting and starting streaming. So here we'll see the example how we can use the Gumlet in real life, and we'll see their product demo how we can make our life easy by using this tool. So these are the benefits of using Gumlet. This is a secure, very much secured. Security is the first in their geo-blocking secure videos playback with the sign URL for unworried streaming and media delivery. Reliability is built in, built to scale, comprehensive supports, developer friendly and simple pricing, and this is very easy to use. We just have to do the sign up and post that. Now here, this is the Gumlet website. From here we can find it out the product. First we have to register ourselves. After registrations, so I have already registered. Once I will click on sign in, I will be able to jump in the screen. So this is our dashboard where we can see how many bandwidths we have consumed, bandwidth saved, and average CDN response time. We can also see the total bandwidth. So I've just logged in with the trial version. So you can also register your own and use this trial products. Here we can upload the video CMS collections profile. So let's understand or upload one video and see how we can process a new video. It's very simple to use it. Now let me show you one video which is I'm having in my system.
Hi everyone, welcome to our new topic of IPTV and STV, that is MPEG dash. So basically in this session we will learn.
So if you can see here, this video quality is very low because I have converted or made this video as very low. So now we'll convert this video into Gumlet format and try to improve the quality of this product. So I am just giving a title as test demo. Descriptions we can add anything. If you want we can tag this. If you want to use, we can use by default setting profile. Otherwise we can select these are the options. So if you want to use select output formats, we have the output format is HLS, MPEG dash and MP4. So let me go ahead with the MP4, or otherwise I will keep my small setting. Let's see the resolutions. So here we have resolutions on different scales like 240. So we can also see or change the resolution according to our requirement. MP4 creation is also possible as a version wise. Per type encoding is also available. We can also add metadata. Video codecs are S264 and S265. Apart of that, we can also add DRM if we want to enable the DRM. trimming and thumbnail options like crop options, overlay and padding options, generate subtitles. So these all settings are already provided here. Now I'm going ahead with the profile setting. At the time of creating my account, I've used this. So here let me select the video. I'm selecting this video. So now the video size is 22 MB. This will again compress this video, convert into the high resolutions and give it to me for high quality product. We can also manage this video into this dashboard, so I will show you. Let's first perform the conversion operations. Or now if we want, we can download this video, or again we can play it here as well. So it's totally up to our requirement how we want to play it. Now this is optimized. Still it's optimizing, because of that this is showing like this here. So let's wait for. So there are various steps are involved here. So first it will upload the video, then optimizing, then processing, and post that it will generate the downloaded link. Now our video is ready to play. Here I'm having access.
Hi everyone, welcome to our new topic of IPTV and STV, that is MPEG dash. So basically,
so if you can see here we have the options to playback, and apart of that we can filter it out the way, we can look it up. So it's very easy UI. Collections, in terms of collections, we have all these collections are available. What is our profile we have, we can see our complete profile. Usage analytics, we can see the complete usage analysis report here. So how much storage we have consumed, which all parameters we have utilized. So streaming uses we have not used that, but storage uses I've used for 1 minute. We can also see the video inside, which is a very amazing contents are available here. So here we can see how many unique users who has played this video. See, these all parameters are available: playing time, playback completed by the users. So these all are the video insights are available, just like a Google Analytics, where we can see everything in one click. So billing informations and API key, these all factors are also here in Gumlet dashboards, where you can do sign up or try the trial versions, and after registering, and you can utilize or have a look about their product. They will also having API references, where we can see image API references and video API references. These two references are available here. So in similar way, we can also convert for images as well. So these all are the documentations of API, where we can create asset and use it the API control in Gumlet, which is an amazing tool to convert or to improve the quality of the video and images, and we can download it these video for our regular uses as well. So that's all from this video. Hope you enjoyed this content, and if you have any queries or questions, please add in the comment sections. I will definitely try to revert it back. But if you have any suggestion about this products, again you can add in the comment sections. Thank you for watching.